All right, good morning. We're going to be working on section 10.2, which is measuring arcs and angles. So we're going to start just going over some basic notes and maybe some example problems. This won't be the full section. This will only be part 1, so make sure you look for a part 2, which will be coming probably tomorrow. So let's get into the notes here. So the first thing we're going to look at is what is a central angle. So a central angle is simply an angle with a vertex in the center of the circle. And that part's typed in for you into the notes. All you need to do is put the drawing and the little descriptor of the drawing here that I have. So in this circle, circle B, we have an arc, right? We have an angle. That angle is ABC. Because ABC has a vertex at the center, B, then that is called a central angle, right? An angle with a vertex at the center of a circle is a central angle. So angle ABC is a central angle of circle B. The sum of the central angles, this should be something you probably already know. This is the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees, right? If there's 360 degrees in a circle, then if we have all of the angles that make up that circle and add them together, it should make sense that it's 360. So if you look at the drawing I have, right, I have 3 angles labeled, angle 1, 2, and 3. All of those angles have a vertex at the center of the circle. So therefore, if I take their measures and add them together, I should get 360 when I'm done. All right, now for our first example, right, we have 2 examples here. Let's go over example 2 actually first. 2 is a little easier. So in example 2, in the drawing, they gave you 2 angles, 165 degrees and 145 degrees, and they ask you to find the third, which is x. In a circle, all of my central angles, as long as they have no common interior points, should add to 360. So all 3 of the angles together should add to 360. So I just solve for x. So 165 and 145 is 310. Subtract the 310 over, and I'll get x is 50 degrees to complete the 360 that I need. Same idea in this circle, except there's just a little bit more going on, right? There's more angles, there's more variables. Doesn't change the process though, right? In this one we have 5 angles. I'm going to take all 5 of those angles, add them together, set it equal to 360, right? Because all of the central angles should add to 360, and they have no common interior points. So if I look at all the x terms, 4, 8, 13, 5, and 20, if I add all of those like terms together, I come up with 50. If I add my constants, 12, -4, -3, and 5, I get 10. So add that to 360, subtract the 10 over, divide by 50, you get x equals 7. Right, so not that bad. Add the central angles to 360 and solve. All right, moving along, we have our definition. We have a couple definitions here that we're going to go over kind of all at once. And these are all in your notes as well. So it says, what is an arc? Well, an arc is just a portion of the circle defined by 2 endpoints. The measure of an arc is the same as the measure of its central angle, or the angle that's opening up to the arc. Right? So it's a portion of the circle, and it's defined by 2 endpoints, and the measure of that arc is the same as its central angle. That means if we add all the arcs of a circle together, they should also be 360, just like the central angles. A minor arc is the shortest arc connecting 2 endpoints, always less than half the circle, and the measure is always less than 180 degrees, half of the circle. A major arc is the longest arc connecting 2 endpoints on a circle, and it's always greater than half the circle, which means it's always greater than 180. And then we have a semicircle, which is an arc with 2 endpoints that lie in a diameter, which means it's exactly half of the circle, and its arc measurement is always going to be 180 degrees. So I have the drawings down here. You'll look at my first drawing. The first drawing is for a minor arc. Now, when it says the shortest distance connecting the 2 endpoints, you'll notice that if I'm going from A to B, I can either go from A to B this way, or I can go from A to B this way. If I take the shortest route, that's the minor arc. If I take the longer route, that's the major arc. right? So a minor arc is the shortest distance between these two endpoints on my angle, right? This ACB, these two endpoints I'm connecting. That's the shortest distance, a minor arc. And you'll note that a minor arc is denoted with the two endpoints with the little arc symbol over top of it. A major arc, the longer way around, is denoted with three letters, right? The two endpoints and then another point somewhere on the arc, in this case, point D, with the arc symbol over top of it. All right, so the angle ACB is the same in both of these arcs. It's just that this arc connects the shorter distance, this arc connects the longer distance. And a semicircle, because a semicircle is greater than, it's equal to 180, that's not less than 180, so it has to be a major arc, which has the three letters with the arc symbol over top. Same idea, two endpoints which are on the diameter, and another point somewhere on the arc when you note it. All right, so I have my note here at the bottom, and I pointed it out. Minor arcs have 2 points, the endpoints of the arc. Major arcs have the endpoints and one other point, so they're denoted with 3 points instead of 2. All right, so that is our notes for arcs and central angles. I have one example here and one more definition. So if we look at this circle here, right, the first one asks us for the measurement of arc X, Z, Y. So if I follow in order, X, Z, Y, right, it's connected by a diameter. If it's connected, the endpoints are on the diameter, it would have to be a semicircle, and a semicircle would have to be 180 degrees. If I go from W to Z to X, that's this whole thing out here. Well, we know that central angles or arcs or just circles in general add to 360 degrees. I know that this piece here is 90 because this angle is 90. Central angles and central arcs have the same measurement. So what's 360 minus 90? 270 degrees. And then XW, this minor arc here, like I said, has to be the same as the central angle. Central angle is 90, and the arc is also 90. Okay. And one last definition, congruent arcs, just arcs that are the same measure. They have to either be in the same circle or congruent circles. So arcs in the same or congruent circles that have the same measure would be congruent arcs. And I think that's kind of intuitive with all of the different congruent statements we made before with line segments and things of that nature. So that's the video for today. Be looking for a part 2 coming soon, and make sure you complete the problems that I put out. Make sure you like, subscribe, and comment if you have any questions. See you next time.